Hey everyone, welcome back. In this video, we're going to be solving the TwoSum algorithm. And in this algorithm, given an array of integers and a target number, we're going to return a new array that contains only two numbers from the input array that, if added, would sum up to the target number. Okay, so let's take a look. If we had an array like this of numbers, here it's 1 to 10, and I've also included 2, and you'll see why in a little bit. And we passed that array, nums array, to the TwoSum function along with a target number. This would return 1 and 8, and 1 and 8 being a pair of numbers that would equal 9. Right? So this would tally up to be 9. So 1 plus 8. Same thing with 4. If we passed in 4 this time, 1 and 3 would be the returned array of two numbers that, if added, would equal the target number. Right? Now, I want to point out that there are multiple matching scenarios here for 9. Let's say there's 2 and 7. Right, 3 and 6, 4 and 5, okay, 7 and 2 over here also, as well as for the number 4, right? 1 and 3 was the first match, and 2 and 2 is the second match. Okay, so for the bonus, we want to return all matching pairs. That would be the ultimate bonus. So, but for the requirements, only to return the first two numbers, matching pair, and for the bonus, all matching pairs. Okay, so let's start with the array, and I just want to cover two possible ways to find these matching complement pairs. Okay, complement being the two numbers equal a target number and thereby are complements of one another. So one way to do this would be to add numbers, and another way would be to take the number and subtract it from the target number to get its matching complement. So these two numbers are obviously complements, equal 9, and 1 minus 9 is equal to 8. And so we'd be looking for the number 8 inside of the array. So for the first solution, or for the first approach, you would start with the number and then add that number to the following number. So 1 plus 2, well, that's 3, that's not 8. So you go 1 plus 3, that's 4, that's not 9. And then you would do the same, and then we change it up for the second scenario, where you would take 1 minus 9 is 8. So we'd start with 1, we'd minus the 9, we'd get 8, and then we'd search the rest of the array looking for that number. And when we find it, we then have our complement, and we could then return an array with those two numbers. Okay, so let's get started here. I'm going to start off by doing a nested for loop. Once again, we're just looking for the first matching pair. So I'm going to start with a nested for loop, and in this approach, it is the most basic approach, an approach most often used by those new to JavaScript trying to solve this particular problem. I'm going to start with the fact that I know I need to complements. I'm going to need to return an array. So I'm just going to start with an array, and then we'll return the complements array. Okay? We're going to work out the logic for this, where we're going to start with our first for loop. For let I is equal to 0, while I is less than array.length, I plus equals 1. And we will then do our nested for loop, where for let j is equal to, and we're going to do I plus 1 because we want our secondary loop to always be or start at the next position. Okay, we don't want to add the same number twice. So if we started j is equal to 0, we'd always be adding the same number, or we'd go back in the past and start adding those numbers up. A lot more work, so we're going to start at wherever I is plus 1 to stay one step ahead of it. We'll do j is less than array.length and j plus equals 1. Okay, so now we have our nested for loop. Let's add and see if we can find a matching pair. So we're just going to say, if array I plus array j is equal to the target number, okay, well, then we would have a matching pair. And so we could say complements array.push. We could push array I and array j and return complements array, and that should work. Let's take a look. Okay, so 1 and 8 and 1 and 3 are returned. If we wanted to qualify for the bonus, all matching pairs, all we'd have to do is comment out this return statement and we'd get all matching pairs. Return statements end the function call, so once the first one was found, this return would simply end the function and return back the array as it was here. Okay, so there we go. Let's go on to the second solution. And in this second solution, we're going to be doing almost exactly the same thing, but we're going to do a single for loop and use index of to find this kind of first matching pair. Okay, and we're going to use this approach right here. We take the number, subtract it from the target, and we find its complement. Okay, now being that we're going to be using much of the same code, I'm really just going to copy this, paste it in here, get rid of the, okay, so here it is. I'm going to get, we're not going to use this nested for loop, right? It's a single loop. Here we're going to say let complement equal to the target minus the current number, okay? And then we'll have some conditional logic here. If array.index of, we're looking for the complement, but we want to start it at the position to the right of where we're currently at, okay? I'm going to start it there, and if that exists, actually here, want to see if the array is not equal to -1, meaning that we want to actually find something that returns back a value, okay? Specifically, index of, if it does not find the element, returns back -1. So we'll leave it at that. Once again, want to make sure that it's not equal to -1. It will return back its position. And then we'll do complements array.push array I and the complements. Okay, and once again here, if we return complements array, we should return outside. Okay, I think this is it. Return syntax, return outside a function. So I must have ended the function. Here's the for loop. Here's the if. And I don't see anywhere else where this thing would. I'm going to do this. Watch. Oh. Oh, you know what? I don't have that line of code. Okay. There we go. That's the problem. Okay. So once again here, just substituting a nested for loop for the array index, and that's where we are taking this number, subtracting it, and then looking through the rest of the array for its complement. Once we find its complement, we then just push it into the array. Okay, that is that solution. Okay, get rid of that. Here we go. Here's the next solution. and this one's using a for each loop. Once again, very, very similar. This time I'm going to use includes instead of index of. Okay, includes will return true or false instead of the index position. And we're going to be using much of this code. So this time I'm going to make sure to copy just the appropriate level of code here. Okay, we are going to be returning. We don't have this for loop, so I'm going to get rid of that. And in here we're going to say dot array dot for each. Okay, and we're going to have the value and the index of the element. And in here we're going to say if array dot includes, okay, once again the complements, which is, we didn't do this yet, so hold on 1 second. So let's do this. Let complement is equal to the target minus the value. And in here we're going to say if array dot includes the complements. Okay, and we're going to start at that index position 1 to the right. Okay, if it does, we're going to say complements dot array dot push, and we're going to push the value and the complement. Okay, looks good. Let's test it. Complements is not defined. Oh, because it's not complements array, it's complements array like that. All right, so this particular solution though returns all of them. So we need to edit this. We can't include, I mean we could include a return keyword statement here, but it doesn't work the same way in a for each. For each will not stop the execution of the for each when it sees this return keyword. So that's not going to work for us. So we have to use some other type of logic to just prevent the function from actually adding it to the complements array. So we're just going to say here if not complements array dot length. That's not true. Okay, if it doesn't contain something, only then push it. If it does contain something, then don't push it, run it, and we have our single use instance. So once again, if we wanted all of them, we just comment this out and we would get all matching pairs. All right, that is the for each solution. And now we're going to move on to this single for loop with the use of an object, this is a kind of neat way of solving it. Okay, so I am going to start with let complements object is equal to an empty object, and we will say let complements array is equal to an empty array. Once again, return the complements array. Okay, make sure there's no typos. Awesome. Okay, so here we are going to go back to our for loop. Let I is equal to 0, I is less than array dot length, I plus equals 1. Okay, so in here we're going to run some logic where we're going to determine if our complement exists inside of the array. So we're first going to define our complement. So complement is equal to target minus array dot I, right? That's going to give us our complement. Then we're going to take a look and see if the complements object, if it contains a key of the complement, does that exist in there? If it's not equal to undefined, okay, then we've added it and we've found the complement. And if we have found the complement, and this is if, not it, then we can we can push it into the array and say val complement, right? We could do that. Let's take a look. That looks good. We have one more thing that we need to do, and that is, say we don't find it, or we want to find multiple instances of complements. We would then take the complements object and set a new key equal to, doesn't really matter, what it's equal to is irrelevant. because what we're looking to do up here is to see if the key exists. If the key is there, that's all that's important. The value that returns is insignificant. Let's take a look. Okay, val is not defined. Because val is not defined because it is array I, right? All right, that's why. Val is not defined. Where is it? Okay, once again, array I. Okay, and in this instance we have, this doesn't look like it's giving us, well, it is. It's giving us all of them, but it's not giving us in that order that we assumed. And I'm going to swap this around because you see how it's, at least over here, it's 8 and then 1 because it finds the complement and then the number 1, right, in both of these. But they're the same matching pairs, 5 and 4, 6 and 3, 7 and 2, 8 and 1, and 2 and 7. I am just going to swap these out to say here's the complement and there it is. So at least we can have it in the order that those numbers were in the array itself. But the reason why these two numbers are over here is because when we grab 1, 8 didn't exist in the object. It was only until we grabbed the number 8 and we subtracted 8 from 9 and we got 1 where we then queried it and did find 1. So they weren't added until much later in the loop. Okay, so that allows us to find the 1, and if we wanted to, oh, that finds all of them. If we wanted to just find 1, we could return complements array, and we'd only get, here we're getting the first matching pair. Once again, in this instance, we find the first matching pair closest proximity to each other. Okay, and 4 and 5 inside of this array, let's go back up here real quick, are the two numbers that are closest to one another. Okay, just another way of solving this particular algorithm. Let's comment this out. Let's move on to reduce. Cool. So reduce is one of those array methods that I push everyone to learn. It's for each, map, filter, and reduce. And reduce is pretty significant in JavaScript. And the concept of reduce is used elsewhere in React and Redux. So we're going to start here once again with let complements object. We're still going to be using this kind of object approach to solving it. And then we'll let the sum, or we're going to say complements, maybe complements. I'm going to call this complements, is equal to the array dot reduce. Okay. And we're going to have the accumulator, the value, and the index of that element. Okay, now if you're new to reduce, reduce includes not only the value that you're currently working in the loop and its index position, but some sort of accumulator with the idea of reducing the array to something. Okay, maybe one single value or a subset of those values. Now the accumulator can either be the first element in the array, or we can define it right here where we are going to set it to be an empty array. So we don't really have a complements array, but this really becomes our complements array. Okay, so in the loop I'm going to say let complement is equal to the target minus the value, and we're going to say if, once again, the complements object obj complement, okay, is not equal to undefined, okay, then we are going to take that accumulator array and push the value and the complement. Okay, see what happens here. Let's move it over a little bit, and getting, oh, you know what, because we're not returning the complements. Okay. Okay, let's take a look and see. Oh, here we go. Really key thing to remember about the reduce method is inside of the reduce method we must always return back the accumulator. So here I need to return back ACC, which is the accumulator array, and we still don't get it. All right, so let's take a look and see if complements object, right? Complements, it's not equal to undefined, then push value and the complement for, oh, here we go. Here's one more thing. Okay, the complements, we're still following that pattern of if we don't find it, we need to store that key inside of the object. Okay, there we go. Now it works just like it did before. Okay, and once again, if we wanted to only return the first matching pair, we would just say something like if the accumulator dot length already exists, okay, then we're going to run that code. Okay, boom. So 5 and 4 and 3 and 1. If we didn't, then we can just comment this out, right? Comment that out, and we return all of those matching pairs. Awesome. And for the last solution to this problem, okay, so the last solution is going to be one that uses recursion, which is always a cool way to solve a problem and something students almost always struggle with at the very beginning. So what you'll see here is I've added complements, kind of a default parameter here, right? And we're setting it equal to an empty array, and so it expects something. So I'm passing in an empty array here, and so it does expect something, although we are passing it in right here and setting it to an empty array. Okay, but we still have the array and the target number. So that's the first nuance to solving it in this particular way with recursion, although there's multiple ways. So in recursion, there's this concept of base case. Base case tells the function when to stop running. Okay, when not to call itself, when to stop running, or when not to call itself. Okay, and then there's the recursive case, and the recursive case tells the function to call itself. Okay, and that's what makes the function continuously loop over itself. So with the base case, we have to make a decision on what are we going to use as the criteria to stop the function from calling itself. So what I am going to do here is this. Watch. Before I do the base case, I'm going to kind of clarify what the base case will mean in regards to this. So I'm going to say let value equal to array.shift. Okay, and so array.shift will remove the first element from the array, and it's a mutation method. So with every iteration, this function is going to mutate this array and remove a value, ultimately leading to the point where the array.length doesn't exist anymore. It doesn't have anything. It's 0, right? And then we're going to say return. At that point, we will return the complements array. Okay? So if we keep popping it, then at some point in time, the array that we pass in will have no more values. It will have a length of 0. And if it's not false, which is true, and 0 evaluates to false, then we will just return the complements array. Okay? That's our base case for right now. So let's go here. In our recursive case, we're always going to be removing a value. We're going to say the existing complement is equal to the target minus the value. Kind of normal process there. Then we're going to say if the array dot includes the complement. Okay, and you can see here we don't need to start at the next value over because we've already popped that first value out. So we're never going to find it anyway. It doesn't really matter. Then what are we going to do? Well, we're going to do the complements array.push, and we are going to push the value and the complement, right? Okay. Now the function still needs to iterate over itself, and here we are going to return TwoSum, or we pass back in the array where we pop something off, the target value again, and the complements array. Okay, this looks good. complement's array. All right, so let's run it, and seems to work. It's returning all matching values, right? And one thing I want to note here is for the second test here, it returns nothing, and that's because we've mutated the array to the point where we've stripped off every value. So I have to comment that out in order for this to work, unless I was to hard code and pass in an array here. But if we're using the array scoped within the script, every time we touch it, it's stripping something away, and we're losing that value. That's what's happening there. Okay, so put that back for now. And the only last thing is what if we wanted to stop when we found a single match? Okay, well, we can't do this because this cycles through them all. All right, so this is the all case scenario. So I'm going to say if, let's see, complements array dot length, right? If this actually does exist, which means we found a matching pair, we're going to return the complements array. Okay, let's test it. Boom, 1 and 8 and 2 and 2. And it actually runs now because the numbers 2 and 2 existed in the array at the time that we ran this. So if I do comment that out, still run. Oh, comment that out, still runs exactly as we expected it to run. Nice. Okay. Well, I hope you got something out of this and are now able to solve the TwoSum algorithm 6 different ways, including 2 kind of advanced ways using reduce and recursion. If you like the videos, please subscribe, and more are on their way.